In this paper, we introduce puzzles, unbounded video depth augmentation for scalable end-to-end 3D reconstruction. Fit for 3D reconstruction methods have emerged as a promising direction. Given unposed, uncalibrated images, they directly predict point maps in a shared global frame. However, current approach relied on massive post video, and the limited diversity and scale of available datasets weakened robustness and generalization. As shown on the left, the video dataset often contains substantial redundancy due to a fixed camera trajectory during the capture. In this slide, we start with the quick preview. Puzzle augment 3D reconstruction training by generating diverse novel viewpoints and realistic camera trajectory from single images or video clips, eliminating redundant frames. Puzzle include two main components, images to clips and clips to clips. For the image to clips, starting from a single RGBD image, we partition it into order overlapping patches, simulate diverse viewpoints by calibrating virtual camera posts, and generate augmented pose images with a live depth map for use in 3D reconstruction. Enable fine-grained local reconstruction, a single image failed to provide sufficient spatial coverage for large-scale scenes. To overcome this limitation, we propose clips-to-clips, an extension that operates on video clips by selecting a strategic keyframe to generate multiple diverse subscripts. We begin by uniformly sample frames from a video. A pairwise overlap matrix is computed to measure frames redundancy, with overlap visualized in purple and overlap ratios annotated in red. Low redundancy keyframes are then selected, and the diverse subscripts are synthesized from them using the image-to-clips method. In this example, we compute the frame-to-frame overlap matrix for a video clip and validate frames against a threshold eta. All frames exceed eta and remain candidate. We then select the maximally mutually overlapping subset from third to fifth. Finally, we prune the redundancy by discarding frames with a pairwise overlapping row equal to 0.01. The resulting keyframes are frame third to fifth. In this slide, we showed an example of image to clips. From single image as shown in left, the method samples overlapping patches and assigns 6 DOF camera paths to craft video consistent clips, as shown in right, turning a single frames into diverse, realistic training sequence across a human, indoor, and outdoor scenes. In this slide, we showed an example of clips to clips. In the top row, the consecutive frames from our original training clips. In the middle row, the selected keyframes with corresponding patches selection. In the bottom row, the synthesis video clips generated from keyframes using the image-to-clips method. Extensive experiments show that integrating puzzles into existing video-based 3R series pipeline consistently improves reconstruction quality under the same training dataset budget. Remarkably, models trained on just 10% of datasets, when augmented with puzzles, match or exceed the performance of the models trained on full dataset. Notably, puzzles require no change to network architectures, making a drop-in, plug-and-play solution. Side-by-side 3D comparison on real-world capture video, standard 3D reconstruction in the left versus puzzle augmented result in the right. showcasing the richer structure detail and more complete geometry. Thanks for your watching. More results and the source code are available on our project page.